In 2.3, we're going to continue with transformations. This time we're going to be stretching out our graphs and shrinking them. And then we're also going to reflect them. We're going to flip them over the X and Y axis. The first transformation we're going to look at in this section is called a vertical stretch and shrink. So again, when we think vertical, we think a vertical line, we think Y-axis. So if I think about stretching or shrinking vertically, a stretch would be going maybe up on the y-axis, and a shrink would maybe be going down. So let's say we have this number c, some real number that's greater than 1, and we take our function and we multiply it by this value c. So the function has already done its job. I'm just taking c and I'm multiplying it by the y value. So what that's going to do is make our y value bigger, and hence it's going to stretch vertically by a factor of c. Now if I have a number c that's between 0 and 1, say a fraction, and I multiply my y value by some fraction, I'm making it smaller, so it makes sense that it's going to shrink by this factor. And that's exactly what I expect to happen. We'll look at this particular example. Y is equal to the square root of x. And if I graph my basic or parent function, I get the point 0, 0, 1, 1, 4, 2. We'll go ahead and graph that. 0, 0, 1, 1, 4, 2. And then the next equation is going to be y equal to 2 times the square root of x. So since 2 is greater than 1, I expect that my graph is going to stretch up. When we put in 0 for x, we get back 0 for y. If I put in 1, I'm getting 2. And if I put in 4, square root of 4 is 2, 2 times 2 is 4. So notice that your y values are getting larger. Makes sense that this graph is going to go up, and it does. 0, 0, 1, 2, 4, 4. And in fact, these y values have gone up by a factor of 2. So when y was 0, 0 times 2 is 0, so that stayed. But when the y value was 1, so in our basic graph we were passing through the point 1, 1, so a y value of 1, what happens now is that we have a y value of 2. And then when we had a y value of 2, it became 4, because 2 times 2 is 4. So again, we're stretching it up. In the last equation, we're multiplying the square root of x by half. So I think it's going to shrink, which it does. Put in 0, you get 0. Put in 1 for x, you get 1/2 for y. Put in 4 for x, y value is 1. It's going to pass through 0, 0, 1, 1/2, and 4, 1. And the graph has done exactly what I thought it would do. It shrinks down. So remember, when x was 1 in our basic graph, y was 1. But now it's half. When x was 4 in our basic graph or parent graph, the y value is 2. But this time when x is 4, my y value is 1, because I multiplied 2 by half and I got 1. So these graphs do exactly what we think they're going to do. Multiply by a number greater than 1, stretches up. Multiply by a number less than 1, between 0 and 1, it shrinks down. However, the horizontal stretch and shrink does the opposite of what we expected to do. And that's because we're changing our x before the function has done its job. Now remember, in our prior section, when we were looking at our horizontal shift left and right, it did opposite of what we thought it would do. if we were subtracting a value from x, you would think you would go to the negative direction or left, but we actually went right. And when we're adding to the x and making it bigger, it actually went left into the negative direction. And that's exactly what's going to happen with our horizontal stretch and shrink. It's going to do the opposite. When we think it should be getting bigger, it's actually going to get smaller. And when we think it's going to get smaller, it actually gets bigger. So let's say that we have some number greater than 1. And we multiply our x value by this number before the function has done its job. Then that's actually going to shrink the graph horizontally. So when we say shrink the graph horizontally, we're like squishing it in or compressing it along the x-axis. And when we stretch it out, we're stretching it out along the x-axis. The factor is not going to be just this number c, though. It's actually 1 over c. It's kind of the opposite of what we think it's going to do. And in fact, I don't even think your textbook mentions what factor you have a shrink or a stretch horizontally by. And your textbook doesn't really focus on the horizontal stretch and shrink, which is fine. But when we get into Math 140, it will become important to talk about a horizontal stretch or shrink. So I would like to mention it now. Let's say that we multiply our x value by some number between 0 and 1. You would think that would make it smaller, but it actually stretches it out horizontally, again by a factor of 1 over c. A particular example, we'll look at y equal to the absolute value of x, and we will graph our basic or parent graph. So it's going to pass through 0, 0, 2, 2, negative 2, 2, 3, 3, negative 3, 3, and graphing 0, 0. We have our 2, 2, negative 2, 2, and our 3's. So we get that V graph of our absolute value. If I look at y equal to absolute value of 2 times x, since 2 is greater than 1, by that definition, it's going to shrink horizontally. So it's going to compress in towards the y-axis, I think. We'll graph points. Put in 0 for x, you get 0 for y. If you put in 2 for x, the absolute value of 4 is 4. And then negative 2 will also give us a y value of 4. Put in 3, we get 6. Negative 3, we have 6. Graphing those points, 0, 0. We're going to go through 2, 4, and negative 2, 4. 3, 6, negative 3, 6. So you see how this V has squished in towards the y-axis. So that's what we mean by a horizontal shrink. It shrinks in horizontally, which just means it's compressing into the y-axis. Now, it's kind of difficult to visualize this idea of a factor of 1/2. Let me see if I can explain this. Let's look at our basic graph, and I'll look at this horizontal line. So this is when y is equal to 2. So notice that when y is equal to 2, we have an x value of 2 and an x value of negative 2. Let's look into the graph that we had when we multiply x by 2. So again, the y value is 2, but look at our x values. 1 and negative 1. So we've actually taken our original x values of 2 and negative 2 and multiplied them by 1/2. Not 2, by half. So we shrunk it in by half. Hopefully that makes sense. Now let's look at the last equation, y equal to the absolute value of 1/2 x, and we'll plot points. So again, I can see by the definition that this should stretch out horizontally. So let's see what that looks like. If I put in 2, I get the absolute value of 1, which is 1. Negative 2 also gives me 1. 3 gives me the absolute value of 3 halves. And then negative 3 will give me 3 halves as well. So if I were to graph it, I got to be careful because 3 halves is equal to 1.5. So you might want to write it as a mixed number or a decimal when you graph it. We'll go ahead and graph these points. We have 0, 0, 2, 1, negative 2, 1. 3 is going to be 1.5. Negative 3 is 1.5. So you could see what I mean by it stretched out horizontally. So we're pulling it out. Let's go back to this idea of y value being 2. So now we multiplied our x value by 1/2, but then look what happens to these x values. My graph's a little off. Where in my basic or parent, my x value was 2 when y was 2. Now I've doubled it. It's 4 when y was 2, because the factor is actually 1 over 1/2, which is 2. So again, it's very difficult to visualize, and that's probably why this textbook doesn't really focus so much on a horizontal stretch or shrink. And neither will I for Math 135, but just be aware that in Math 40, we will be looking into this idea a little bit further. The last type of transformation we're going to look at is a reflection. So we're going to reflect across both the x and the y axis. And this should remind you of what we did when we talked about symmetry or even and odd functions. Let's look at our reflections. Let's say that we have some graph f of x. Then if you take negative f of x, that's going to reflect about the x-axis. So remember, the function did its job. It's giving us back a y value, and then we're going to make it negative. So what that essentially does is it changes any positive y values to a negative y value, or a negative y value to a positive y value. So you think about y values going from positive to negative, that would reflect over the x-axis. Now let's say that we take our function and we replace f of x with f of negative x. So again, this should look like something we did with symmetry or with even and odd functions. When you replace x with negative x, you're changing your x value from negative to positive, positive to negative. So that would be a reflection across the y-axis. We'll look at specific examples. I really like reflections. So let's say y is equal to the square root of x. Again, our basic graph would be 0, 0, 1, 1, negative 1. Ooh, that does not exist. It's undefined. So I'm just going to leave it blank. It doesn't exist. And then if I put in 4, I get 2. Negative 4, undefined. So let's graph. We have 0, 0, 1, 1. Negative 1 doesn't exist. 4, 2. Negative 4 doesn't exist. All right, so now let's go ahead and graph our next function. Let's bring the negative on the outside, put in 0 for x, we get 0. Put in 1 for x, we get negative 1. Put in negative 1 for x, it does not exist. If we put in 4, square root of 4 is 2, but it's negative 2. If we put in negative 4, that does not exist. So since the negative is on the outside of the function, by that definition, I think it's going to reflect across the x-axis. So reflect across just means mirror image. Let's see if that's what happens. 0, 0, 1, negative 1, 4, -2. Yes, it reflected across the x-axis. Now what happens when we bring the negative underneath the square root? So if we put in 0, we get 0. If we put in 1, doesn't exist. -1, a -1 is a +1, so that would be 1. Put in 4, doesn't exist. -4 becomes a +4, and we get 2. So I'm thinking I'm going to take my original graph and I'm going to reflect it across the y-axis. 0, 0, -1, 1, and -4, 2. And that's exactly what happened. All right, so now we have all of our transformations. We have moved things left and right and up and down. We have shrunk them. We have stretched them out. We have flipped them over the axes, and we're going to put it all together. In example 1, we want to write an equation in x and y that results in the desired transformation. Notice we no longer say translation because the translations were only for left, right, up, down. These transformations in 2.3 are not translations. So let's say we have a cubing function in part A. So the cubing function would be x to the third. We're going to vertically stretch this function by a factor of 3, but we're also going to reflect it across the y-axis. So if it reflects across the y-axis, then it's actually your x's are going from positive to negative and negative to positive. So you're changing the x's. Cubing function is x to the third. We're going to stretch it vertically, so that's outside of the function. But we're also going to reflect and change our x. So that's what the equation would look like. Let's try another one. Part B, we have the absolute value function. Okay. And we're going to vertically shrink it by a factor of half. And then we're going to reflect it across the x-axis. So if we reflect across the x-axis, that means we're changing the y value. So we're going to put the negative outside of our function absolute value of x. So the negative is going to go outside of the function, but also remember that we're shrinking it vertically by 1/2. So vertically shrinking means outside of the function as well. And that's how we would write this. Let's change this around. Let's say that we have an equation and we want to describe the transformation. So in example 2, we want to describe the transformation from our function f to our function g. So we have our function f of x. We didn't do anything to the x. We have this -4 on the outside, and then we have a +2. Ooh, I'm adding in some transformations from the prior section. Something to remember is that the 4 is one transformation and the negative is another transformation. It's not -4, a single number. It's the negative, which would be a reflection, and the 4, which would be a stretch or a shrink. Now, since the 4 is on the outside of the function, that would be a vertical stretch. And then the negative is outside of the function, so that would be a reflection across the x-axis. And then we also have this +2 from our prior section. That would be a shift up. So we would describe this as a stretch. Well, actually, probably should say since it's on the outside, we should say a vertical stretch. So we're going to stretch this vertically by a factor of 4. Well, try writing that with 2 words. Talking and writing. So we're going to do a vertical stretch by a factor of 4. We're going to reflect across the x-axis. And the last thing we're going to do is shift upward 2 units. Okay. Now, it becomes very complicated when we do a combination of transformations. So now we have a bunch of transformations. I am going to differ from your textbook. First of all, they really don't mention this, and they should. They should mention that your equations should be in the proper form where the coefficient on your x value is 1 before you can even discuss the transformation. And they have 3 orders of graphing, and I don't. I do a little bit more than they do, and I get more detailed. So the order when graphing, this is my preference. This is not the preference of your book. Your book says it in a different way. No matter what, you should always do anything that affects your x's first. So that would be these first 3. You want to do a horizontal shrink or stretch first, and then reflection across the y-axis. So that would be if you make positive x negative, negative x positive. So these are all things that are affecting the x value before the function has done its job. And then I do my shift left, right, last. Then we're going to do our y's. So vertical stretch or shrink, any reflection across the x-axis. The last thing you always do is your vertical shifts. This, no matter if you're following what the book says or what I says, this is always last. Okay. Now the reason why they just do these 3, what they do is they do actually a horizontal shift first, and then for second they do any stretch or shrink, doesn't matter if it's vertical or horizontal, and reflection. They do all of that in number 2, and they let you choose the order you get to do it in. Their number 3, their last thing, they only have 3 in their order, is the vertical shift last. So that's where we do agree. And the reason why they only have these 3 is because they do have a little note in the book that says when an equation is written in the typical form, then it's those 3. In this book, their typical form doesn't really address horizontal stretch or shrink, but I will. So I want to make sure that we have good habits. In example 3, this is something that your book doesn't do. This is something that I'm doing. We're going to write the equation in the proper form and then describe the transformations. Part A, we have y equal to 2 times 4x minus 2 squared minus 7. The proper order is that the coefficient on the x is 1. This has the coefficient on the x as 4. So I need to factor out that 4 to get this in the proper order. I'm going to have y equal to 2. And here I'm going to put a bracket and then factor out the 4. So in parentheses, if I factor out the 4, I'm going to have x minus, so remember when we factor, we're dividing. So 2 divided by 4 would be 2 over 4, or 1/2. If you're not sure, then you can double check by distributing that 4 back through and seeing if you get back to the original equation. So that's what I meant by the coefficient on the x has to be 1. If it's anything else, factor it out. Because now notice that the x minus 1/2, that minus 1/2 is going to be your horizontal shift. It's not minus 2 as the original equation says. because we need to make sure that x is by itself and we factor anything out. Now that I have it in the proper form, I can go ahead and describe the transformations. So notice that this 4 in front means that it's going to be, and we're affecting the x now, this is going to be a shrink by 1/4 or 1/4. So we're going to do a horizontal shrink by a factor of 1/4. Again, your book will not do this. They focus mainly on vertical stretch and shrink. Once I've described that, let me go ahead and underline this. So we've talked about this 4. Now I'm going to go ahead, I'm working on my x's first. I don't have a reflection across the y-axis. Notice it's not a -4, but I do have this -1/2. And that would be, since it's a -1/2, it's going to be a horizontal shift right by ½ unit. Or just a shift right, yeah. Okay. So now that we've addressed the 4 and the -1/2, we're going outside of our square function and we see this 2 on the outside. That would be a vertical stretch. And we're stretching by a factor of 2. The last thing we always do, whether you're following my way or the book's way, is any up down. So that -7 is going to be a shift down. So I could say a vertical shift down, but I think I'm going to be lazy and just say shift down or downward. So if we're going to shift down 7 units, or shift down 7 is fine. Okay, so again, make sure you have things in the proper form. Coefficient on x is 1. So you might have to factor something out before you decide what the transformations are. In example B, there's a -1/5 in front of the x. I need to get rid of that. So this is going to be y equal to -3. And underneath the square root, I'm going to factor out the -1/5. And then that will give me, so factoring out means I'm dividing, and I'm taking out a negative. So that plus will turn into a minus. I never make these long enough. And this is going to be a 5. So if you're not sure, multiply the -1/5 back through, you'll get -1/5 x minus is plus 1/5 times 5 is 1. You'll get back to where you started from. Now this +6, this is on the outside of the square root. That's not underneath the square root. Now that I have it in the proper form, I can describe my transformations. Just be careful. Remember that this 1/5 is one transformation and the negative is another transformation. Those are 2 transformations. If I was going to look at the 1/5, that would be a horizontal stretch, because 1/5 is between 0 and 1. Horizontal stretch by a factor of 5, not 1/5. Remember, you're always taking a reciprocal. So we have horizontal stretch by a factor of 1/5 or a factor of 5. So I'm just going to say by 5 because I'm lazy. Let's see, the next thing I want to look at is that negative in front of the 1/5. Remember that negative would be a reflection across the y-axis. So we're going to reflect across y-axis. Now I'm getting super lazy. I didn't even put a the in there. All right. We have this -5. I'm still working underneath that square root. Everything that affects my x, I do first. The -5 would mean we're going to shift right 5 units. So I'm just going to put shift right 5. I'll put units. I won't be that lazy. All right, now that we've done everything underneath the square root, everything that touches x's, we go outside. Remember, the 3 is one transformation, the negative is another. So if we were going to describe that 3, it would be a vertical stretch by 3. Or a factor of 3. I'm just going to say by 3. And that negative would be a reflection across the x-axis. So I'm going to say reflect across the x-axis, so across x-axis. And let's go back up. We see that we have this +6, so we're going to go up 6 units. So shift up 6. So just as a reminder, your textbook is not as complicated as this. They do more simpler transformations and they do not focus on horizontal stretch shrink. But I want to make sure that we're all on the same page here before we move into our Math 140. The last thing we're going to do in this section is graph. And remember, we're graphing shifts, stretches, shrinks, and reflections. We're putting it all together. It can get a little bit confusing. So this is where it's a good idea to use either a graphing calculator or Desmos to maybe graph this transformations in the order that you're graphing and compare it to your final graph. See if you've done them in the correct order. Example 4, we're going to sketch the graph of our function. Again, we're not going to plot points, but we're going to start with our basic or parent function and move it around. So whenever we graph our basic or parent function, we are still going to plot points because it's those points that we're going to be moving around. Let's see. So a is y equal to negative parentheses x minus 2 squared plus 4. So if we take away all these minuses and pluses and all the numbers, we have our parent graph, which is simply x squared. And I know how to graph that. Let's see, it'll pass through 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. We should all be very familiar with these graphs that we keep graphing over and over again. Okay, so I want to do everything that affects x first. And now the only thing within the parentheses is this -2. So this -2 is going to be the first transformation that I graph. That says that I'm going to shift the graph to the right 2 units. I'm going to go from 0 to 2, 1 to 3, and then here at 2, 4. Let's see, 1, 2, 1, 2. I think I got it. Well, maybe I'll just keep it as blue. Okay, let's double check and see if I've moved everything over 2 units. It looks like I did. All right, the next thing I need to do is go outside of the x values, and I see this negative in front of the parentheses. That would be a reflection And this time we're going to reflect about the x-axis. So all the positive y's become negative. Maybe I'll label this one. Okay, so if I'm at 2, 0, I stay there. 3, 1, that y value of 1 is going to come down and be a -1. I should probably do a different color. And then at the point 1, 1, that positive 1 y value will now be a -1. The positive 4 becomes a -4, and then this 4 becomes a -4. I think I got it. All right, so I have reflected the graph about the x-axis. That would be my second transformation. The last transformation I have is this +4. So remember that +4? That is going to be a shift up by 4 units. I am going to take, what other colors have I not used? Maybe I'll use black. I'm going to take these y values, I'm going to shift them up 4. So 1, 2, 3, 4. 1, 2, 3, 4. 4. This goes 1, 2, 3, 4, and 4. Okay. So let's see if I actually graph this correctly. You can check if you're not using a graphing utility, you can check by looking at the points on the black graph. So this is my final graph after I've done my last transformation. So this should be the graph of y equal to negative x minus 2 squared plus 4. So let's say I put in an x value of 0. If I put in x value of 0 on that black graph, I should get back a y value of 0. So if you put in 0 for x, you're going to get -2 squared, which is a +4, but the negative on the outside will make it a -4. So -4 plus 4 is 0, and I do get this point. All right, so let's look at maybe 1. We'll do a few of them. So when x is 1, I should get a y value of 3 because that's what my graph says. So if I put in 1 for x, I get -1 squared, which is +1. But it's a -1 plus 4 gives me a +3. And it is passing through the point I think it's supposed to pass through. We'll try one more. When x is 2, 2 minus 2 is 0, so this becomes a 4, and it's passing through the point 2, 4. So I did use the transformations. I took those key points for my basic or parent graph, and I moved them around. But again, it gets a little tricky because we have a bunch of different transformations now. Well, let's do another one. In part B, we have 2 times the square root of -x minus 4. So again, we're going to look at things that affect the x first. Now, underneath this square root, there's a negative on top of the x. So that means I'm going to reflect across the y-axis first. My parent graph is take away all the negatives, all the numbers, you just get square root of x. So 0, 0, 1, 1, 4, 2. This reflection means I'm going to reflect across the y-axis. So the 0, 0 stays, but the 1 for the x becomes -1. And the 4 becomes a -4. And that's what my transformation looks like. All right, so we have reflected. The next thing we're going to do is this 2 out in front. That says we're going to do a vertical stretch up 2 units. So what does that mean with our graph? It means that all the y values are going to go up by 2 units. Kind of misspoke. I don't mean that it's going to shift up by 2 units. I mean that you're going to take your y values and multiply them by 2, so it's a factor of 2. So it's going to stretch up 2 units. If I have a y value here of 1 and I multiply that 1 by 2, 1 times 2 is 2. If I have a y value of 0, it stays 0. If I have a y value of 2 and I multiply that by 2, it becomes 4. Okay, so I have stretched this up by 2 units. Let's see, the last thing we do is this minus 4. So the minus 4 would be a shift down 4. I'm going to take this point 0, 0 and shift it down 4. I'm going to take this point negative 1, 2 and shift the 2 down 1, 2, 3, 4. And then when I have a y value of 4, go down 1, 2, 3, 4. And I will graph this in black and then double check to see if I did this correctly. So this was my last transformation. So again, you want to check that in Desmos. I am not bringing up Desmos in this lecture. I am actually just checking this by hand, which is more difficult. So let's look at the graph. Our final graph looks like it's passing through x is 0, y is negative 4. So going back to that function, if I put in 0 for x, the square root of 0 is 0 times 2 is 0, and I get a minus 4. Okay, that makes sense. What about negative 1 for x? I should get a y value back of negative 2. So if I put in negative 1 for x, a negative negative 1 is positive 1. 2 times 1 is 2. 2 minus 4 is negative 2. It's exactly where I think it should be. Let's do our last check. We'll put in negative 4 for x and see if we get back 0 for y. So put in negative 4 for x, and negative negative 4 is a positive 4. Square root of 4 is 2. 2 times 2 is 4. 4 minus 4 is 0. So it checks out. We're going to do 2 more. Again, I know these are kind of tedious, so please use Desmos and double check, or your graphing calculator or any graphing device. All right, part C, parent function, take away all the negatives, the pluses, the numbers, and you get y equal to the square root of x. And we know how to graph that. It's going to go through 0, 0, 1, 1, 4, 2. I got my parent. Okay, so this is a little bit different. We have a negative underneath the square root, and we have this plus 2. So something to notice is that the coefficient is not 1. So this is actually y equal to negative square root of negative x minus 2, and then we minus 2 on the outside of the square root. So we're going to take this function and I'm going to do the reflection first. I want a different color. I'm going to do this reflection first, and we're going to go ahead and reflect that. Remember, that's going to reflect across the y-axis. So the 0, 0 stays. The 1 becomes a negative 1. The 2 becomes, or the 4 becomes a negative 4. Okay. Oops. So that would be our first transformation. The next thing we're going to do is the minus 2. So minus 2 means we're going to go right 2. I'm going to take these points and move them to the right. Okay, it's getting kind of squishy here. And then we have a negative on the outside of the square root. That'll be my third transformation. That is going to be a reflection across the x. So I am going to, the 2 stays. So remember, we're switching our y values. So if my y value of 1, it becomes negative 1. If I have a y value of 2, it becomes negative 2. All right. And that was my third transformation. The last thing I'm going to do is a -2. So that means I'm going to take this graph and I'm going to shift it down 2. So the -1 becomes a -3, the -2 becomes a -4. All right. And that would be my fourth and final transformation. Whew, let's double check this. It'd be much easier if you graph this in a graphing utility to double check, but we're going to double check it by hand. All right, so if x is 2, I should get a y value of -2. Going back to that function, if I put in 2 for x, I get 0 underneath the square root, and I get a y value of -2. So let's try 1. If I put in 1 for x, I should get -3 back for y. So if I put in 1 for x, I get square root of 1. And the negative on the outside means it's going to be -1 minus 2. I get a -3. Okay, that works. The last one I'll check is -2 for x. I should get a -4 for y. So I put in -2 for x, a negative makes it a +2, so I get square root of 4, which becomes 2. Negative on the outside means -2 minus 2 is -4. And it all checks out. Our last one. Oh, there's a lot going on here. Okay. So I've kind of been on autopilot here. I've just made sure that everything was written in the right form and so on. And whenever you're dealing with absolute value functions, or maybe maybe the squaring function like x squared, something fun happens if you have a lot of negatives. So let's see what happens here. If I write this as y equal to -3, absolute value of, remember, I'm taking the -2, factoring it out, because I just need x by itself so I can identify the correct transformation. It becomes a +2. Okay, if I distribute that -2 back through, I get -2x minus 4. Yes. So it looks like I'm going to have a horizontal shrink by half, then a reflection about the, this is going to be about the y-axis, but then I'm also going to shift left 2 units. Then I'm going to do a vertical stretch by 3, and I'm going to reflect across the x-axis. It's a lot going on. And normally, if this was any other function, like maybe a square root function, I would be stuck. But think about what this says. Don't get stuck on autopilot. Off to the side, this is y equal to -3, absolute value. So notice that it's -2 times x plus 2. Whenever you have a product in the absolute values, you can split them up. And now the absolute value of negative 2 is simply positive 2. So this becomes negative 3 times 2, absolute value of x plus 2, or y equal to negative 6, absolute value of x plus 2. So if you can do some simplifying in the beginning, that's going to help a lot because that's a lot of transformations. So this is much better for me to graph. So I'm going to graph y equal to negative 6, absolute value of x plus 2. And then I'm going to have this final transformation graph. I'm going to take those points off the graph and I'm going to plug it into my original equation before I messed with it and see if I get the same points. Okay, so first thing I want to do is this plus 2. Oh, no, the first thing I want to do is write my parent function, which is just the absolute value of x. That's going to pass through 0, 0, 1, 1, 2, 2. It's just going to do my v. Okay, maybe I'll just make some dark points here so I can move these around. And then the plus 2 means I'm going to move over to the left 2. So 0 to negative 2, negative 1 to negative 3, and so on. It looks like I have this graph, which would be my first transformation. And then I have a minus 6 on the outside. That says that I am going to stretch vertically by 6. Ooh, I wonder if I can even do that. Let's see. I have a y value of 0. So that's going to stay. But this y value of 1 is going to stretch up to 6. Ooh. Wow, this is going to be really skinny. I can't even graph those other points. And the y value of negative 1 when I multiply it by, or y value of 1 when I multiply it by 6, it's going to be up here. Oops. It didn't make my line big enough, or small enough actually. Okay. So that would be my second transformation. And I only have 1, 2, 3 points because the other points aren't even on the graph. So the last thing I'm going to do is this negative. That's going to reflect over my x-axis, which means the 2, or the negative 2 here, negative 2, 0. The 0 for the y will stay the same. This positive 6 becomes a negative 6. Positive 6 becomes a negative 6. Well, let's see. So this graph is going to be an x value of negative 2. I'm going to check that, see if I get a y value of 0. I'm also going to check when x is negative 1 and x is negative 3. Am I going to get y values of negative 6? Now I'm going to put it in, I'm not going to put it in y equal to negative 6, absolute value of x plus 2, because maybe I did some math wrong there. I'm going to put these points into the original equation. So if x is equal to negative 2, negative 2 times negative 2 is a positive 4. So 4 minus 4 is 0. Absolute value of 0 is 0. I should get back a y value of 0, which I do in my graph. If I put in negative 1 for x, I get negative 1 times negative 2 is a positive 2. 2 minus 4 is negative 2. Absolute value is going to be positive 2. And I get a negative 6. which is exactly the point I passed through. If I put in negative 3 for x, I get 6 minus 4 is 2. So 2 times negative 3 is negative 6. That seems to match the graph that we have. So you see, that was much easier than doing 5 different transformations. Okay, and that is it for this section.